This lesson is on fractions and decimals and converting between the two forms. Jackson and Roy each checked out at the lumber store with a piece of plywood for an upcoming project. Jackson's plywood was 3/5 inches thick, while Roy's plywood was 0.7 inches thick. Who purchased the thicker piece of plywood, and how do you know? It's difficult to compare 3/5 and 0.7 when they look completely different. So we're going to look at how to change from fractions to decimals and decimals to fractions in order to help us be able to compare numbers more easily. Because when I look at 0.6 and 0.7, it's easier to compare them. So Roy's plywood was thicker, and that's much easier to see once we have the numbers in the same form. In order to convert fractions to decimals, we're going to divide the numerator by the denominator, or the top by the bottom. When we do this, we can get two different types of decimals. A decimal that ends or terminates is known as a terminating decimal. A decimal with a repeating block is known as a repeating decimal. So terminating decimals stop and there's not really a pattern. Repeating decimals show the same pattern over and over and over and will keep going on and on forever. And we'll see examples of both of these when we look at converting our fractions to decimals. Let's look at some of our examples. So as we said in our instructions, we're going to divide the numerator by the denominator. So I'm going to divide 3 by 8. And I want to leave myself plenty of room horizontally to make sure that I have room enough to add decimals as they go on. So 8 does not go into 3. So what I'm going to do is I'm going to add a decimal and add a 0. Now I know that 8 goes into 30. 8 goes into 30 3 times. And then I'm going to multiply that 3 times 8 to get 24. Now I have to borrow, and I get 6. I'm going to add another 0 and bring it down. 8 goes into 60 7 times. 7 times 8 is 56. I'm going to add another 0. 8 goes into 40 5 times. And now we have a 0 at the bottom here. So I know that I'm finished dividing. My answer is 0.375, and this is a terminating decimal. The next example is 1 over 16. So I'm going to divide the number 1 by the number 16. Obviously, I know that 16 doesn't fit into 1, so I'm going to add my decimal. But 16 doesn't fit into 10 either, so I'm going to add another 0. And 16 does fit into 100. It fits into 100 6 times. And 6 times 16 is 96. Of course, 100 minus 96 is 4. I'm going to add that next 0. 16 goes into 40 twice. and 16 and 2 multiplied together will give me 32. Bring down that next 0. And 16 goes into 80 5 times. And 5 times 16 is 80. So once again, I've gotten to that 0 at the bottom. So I know that I'm done, and my answer is 0.0625. And because that number stops without repeating, this is also a terminating decimal. The next example is 5/6, or converting 5/6 to a decimal. So I'm going to divide that numerator by the denominator. And I know that 6 can't go into 5. So I'm going to add that 0. I know that 6 will go into 50 8 times because 8 times 6 is 48. I know that 6 will go into 20 3 times. We got 20 again. And now we got 20 again. So we're just going to keep getting that number 20. So what we have here is a repeating decimal. And I can write that two ways. I can write 0.8333 with an ellipses after, or I can put a line over the 3 indicating that that 3 will keep repeating. Notice that the line does not go over the 8 because the 8 does not repeat, only the 3 repeats. Our next example is 4/9. So I'm going to divide 4 by 9. I know that 9 is going to go into 40 4 times. And as you can see, I'm going to get 4 each and every time, because 40 minus 36 is 4. So when I add another 0, that's always going to become 40 again. So this is a repeating decimal, and it's 0.4 repeating. Now I'm going to teach you a trick. Whenever you have a single digit numerator over 9, it just ends up being that digit repeating. So a single digit numerator over 9 will always be that digit repeating behind the decimal. So 3/9 would be 0.3 repeating. 5/9 would be 0.5 repeating, and so on and so forth. Our next example is 13/4. Now this one is a little bit different than the other ones that we've done because we don't have to add a 0 and a decimal right away. I know that 4 goes into 13 3 times. I don't want to use a remainder, I want to use a decimal. So I'm going to add a decimal in that 0. 4 goes into 10 twice. And 4 goes into 20 5 times. I've gotten that 0, so I know that I'm done. My answer is 3.25, and that's a terminating decimal. Our last example for converting fractions to decimals is 7 over 9. Now, that's a single digit numerator over 9. So I know that it should be 0.7 repeating. So let's do our division and see if that's what we get. So I know that 9 doesn't fit into 7, but 9 does fit into 70 7 times, and that gives me 63. Well, 70 minus 63 is 7, so I'm just going to keep getting 63 and having to subtract from 70. So I'm going to keep getting a 7 down here. And when I add zeros, that's going to keep going on and on and on. So this is 0.7 repeating, and it is a repeating decimal.